Okay, hello everyone. Now this is additional video to help you study and learn on chapter 10 and 11, especially for chapter 11. So hopefully this video can help you to study. Okay, let me give you questions. Okay, so in chapter 11 we learn on sequence. Okay, so let me give you a sequence. Just let an start from n equals 0 to infinity. Okay, now we have this statement. Now I have several statements. Okay. Okay, so from this statement, so I have four statements here. Which of the following statements are false? So the question is which statement are false? Or maybe is false? Or maybe which statements are true, which statements false? So we can have more general questions. So stop the video or pause the video and try to solve this by yourself. And later on we can have our solutions. Okay, first, to understand this question, okay, you can see that we have this a0 equal 2 and an plus 1 is 5 minus 4 over an. Okay, now we can write down a0 is 2 and we can write a1 is when n is 0, so we can have 5 minus or maybe like we start by looking at the a n plus 1 equal 5. Start by n equals 0, which is a1 5 minus 4 divided by 2. This will be 3. Okay, and we'll have a2. a2 is 5 minus 4 over 3. This is equal to 11 over 3. Okay, I think, right? It's correct. Okay, now a3 is that it? Okay, I think it's correct. Now a3 is 5 minus 4 over a3 will be n equal 2, so a2 is 11 over 3. So 5 minus 4 multiplied with 3 over 11. So this will have 5 minus 12 over 11. Okay. Now this is almost 1. You can say 1 point something. So we can have this is equal almost 4 something. And if we have 4 point something, then if we have a 4, this will result in 4 point something. So this is also still 4. It's 1 point something, it's 4 point something, right? If you did a5, I believe this will be having 4 point something, or 3.99999 probably. Okay, so from this experiment, from this results for the age of the sequence, we will get the sequence getting bounded to, so an bounded to number 4. So this is correct. And then if we are looking at the how it goes from 2 to 3, 11 over 3, and then 4, we know that it's increasing. And a2 should be 11 over 3. So it's wrong, it's false. And we say that the limit is going to be 4, and that's correct. So the sequence is increasing and bounded, okay? And the limit of the sequence equal to 4, okay? So we will have this is true, this is true, this is false, this is true. Okay, that's how we can solve the answer. Okay, now next question. Let me give you next question. Maybe giving you a determine whether the series absolutely convergent, conditionally convergent, or divergent. Okay, let's start with let me give you okay. Let's start with this. Or maybe let me give you two series. Okay, now pause the video and try to solve these two questions. Now this is two examples from the exercise from your textbook. Okay. Okay, let's work on these two series. Okay, first one, let's start from this one. Okay. Now, whenever you have a series, okay, that has some power like this, and you need to find about the convergences, whether it's absolute or conditional convergent, one thing that you need to try at the first time is using the ratio test. Okay. So we can have or the sequence in n plus 1 compare with the sequence. Okay. Now we can take this, and this will be n plus 2, n plus 1, 2, to n plus 3. Okay. So careful here, what you need to exchange is just n. So it's actually like this. Okay. And then multiply with 2 to n plus 1 divide n plus 1 and 3 power of n. Okay. Work here. Okay. Now we can simplify it. 2 with power 2n, so this is 2, 2, okay, and 3n, this is 3. So we will have n plus 2 over n plus 1 multiplied with 3 over 4. Okay, now we get this result and take the limit as n approaching infinity, and we know that this will result in this is cancelled both, right, for limit, so this will be equal to 3 over 4. So 3 over 4 is less than 1, right? So it means that the ratio test, by ratio test, the series is absolutely convergent. Okay, I think it's not too complicated, right? Okay. Now the next series we have here. Now if you have the ln and the square root, if we imagine like using the ratio test, it doesn't do anything, right? Or even if you want to take the comparison test, I think it's difficult because you have the ln on the bottom side. So probably what you can do is just try divergence test. So take limit of the sequence. Okay, we will see how it goes, and take the limit, and you see that it's going to be infinite over infinite. It's indeterminate forms in which we can have our L'Hopital rule. So this will become this, come here and there. So we will have a limit of square root of n over 2, which is going to be infinite. Therefore, by divergence test, the series is divergence. So whenever you find, if you're using divergence test, if you find any number 1, 2 in your results here, 3 or any number, means it's also a divergence. Or if you find infinite, you also have differences. But whenever you find the limit of n is 0, it doesn't mean it's converged. So it doesn't mean it's converged. We need to apply the other tests. Okay? Okay. Okay, now let's move on. Okay, the next questions. The interval of convergence of the sum So we need to find the interval of convergence of the series. Okay, so pause the video and take a chance to try. Okay, let's start with, so every time you have questions in terms of interval of convergence or finding radius of convergence, what you need to do, the first thing is take the ratio test. Let an is this. Yeah. Okay. Now take ln 1 plus 2 plus 1. Okay. Now this is divided by this x with n plus 1. This is ln 1 plus 2 and x over n. I think we can cancel that. And we don't have this part. Okay. I'll take the limit. Take the limit as n approaching infinity of ln. Okay, now what we are going to do. If you check the limit, it turns out we have 0 over 0 situations. And if this happens, then we take the L'Hopital rule. So we differentiate. So differentiate one part. So half minus half minus half minus 1 is minus 3 over 2. 1. This will be 2. Okay, I think in terms of limit, this will be going to cancel, and this is also cancel. So we will have, so all this can become 0, right? So this is also canceling, right? So what's left is we will have only the absolute value of x. And then it would converge when this absolute value of x is less than 1. So we may have x but we need to check whether we need to include or not. Okay. Maybe we can just write this first. Okay. So check x equal 1. So it will be the series will be ln So what will happen with this? The series is divergent, right? And check x equal -1. If this is -1, then we'll have alternate series -1 ln. Okay. Now we have this. This is a converge. Because it's decreasing, and also it's going to have the limit itself is going to be it's 0, so it's converging. Now this divergent here, we can take this in terms of telescoping sum, if you want. Telescoping sum. Check how the check with 1. Okay. And it's keep increasing, right? It's keep increasing. Check with 2. Check with 3. It's keep increasing. So you see that it's going to be diverged. Okay. So we will have -1 converge, so include, and without the 1. So this will be the answer. So interval of convergence. Okay. Okay, let's move on to the next questions. Okay, now let me give you questions. Find the sum of the series. Let me start with tangent inverse. Okay, let's start with this. Okay, pause the video and try to check your answer. Okay, now this sum of the series, okay, how to solve this? Basically, first, we can check a property of an, okay? Meaning we check n equal 1, 2, 3, and how it looks like. Okay. And the second one, we can relate this series with the Maclaurin series, and then rewrite in terms of the function. Okay, and probably relate to geometric series. Usually these three will be your strategy or your way to solve the problem. And if we look here, one thing that you need to take it as a giveaway is it has this minus. Okay, it seems that probably it has something to do with the patterns. So let's make it this whole series as a limit of our partial sum. Okay. Now we check several nth term. Okay. So in terms of limit, we can say that this will equal, let me put it down here. This will equal, start with 1, okay, start with 2, and then take again, start with 3, and if you see the pattern here, it's 2 minus 2 and then 3 minus 3. So we are going to have this in the front, right? And we will have a series of pattern that is perfectly aligned with the tangent inverse n plus 1 minus tangent inverse n. And as usual, that this, as in the pattern, all this will be cancelling. So we can take the equations, limit, and then take the tangent inverse n plus 1 minus tangent inverse 1. And this will result in tangent inverse that is having infinity is pi over 2. So we can take this as pi over 2 minus 1 is pi over 4. So it should be pi over 4, the answer. Okay. Now another one that we can have, okay. Let me give you directly follow-up questions. Okay, so you need to find the sum of the series. How we are going to solve this? First is, if you want to find the sum of the series, maybe we can take sometimes to imagine if this denominator is separated. Okay, so let's do that. So we can check with, so let me write this. Okay, now we have, let me change the color. So a n plus 3 plus b n is equal 1. So a plus b multiplied by n plus 3a is equal 1. So a is 1 over 3 and a plus b is equal to 0. So b is negative 1 over 3. So we will have 1 over 3n minus 1 over 3 n plus 3. So let's use these equations, okay, to separate this series. And then it's similar with the tangent inverse that we have done before. We take the Sn as a partial sum. Let's use other variable I to mention the integer. Okay. And check from 1, 2, 3, 4, right? 1 over 3 minus 4, 3, 12. It seems 12. Okay, 12. Or let me write in the bottom here to make it more clear. Then plus 618, okay, and then three, 4, 12. Oh, sorry, it should be 9. It should be 12. It should be 21. And when you see this pattern, it's 3 become 9 become 12. Okay, 12 becomes 18 becomes 21. And you will see that this will cancel. Oh, sorry. I think I made mistake. Wrong n. Okay, I think I need to rewrite this. Sorry. So this is I equal 1, right? 1, 1. Okay, and then plus this is I equal 2. Yeah, 1 over 6 first, and then this will be 15. And then this is I equal 3, which is 1 over 9 minus 3, 16, 18, sorry. And then another one is 1 over 12 and minus, okay, now this is, I think, better approach. Now it's not directly canceling, but you will see that every time you have like 1 over 12 and then 1, 2, and the third order after the first order. So 1, 2, 3, you will cancel this. And you will cancel this 1 over 15 when n is equal 5. So 15 will be cancelled here also, and the other part will be cancelling as well. So we will get the at least 1 over 3 plus 1 over 6 plus 1 over 9. Okay, and all this in the place here, it will be canceling. So it's canceling. So we're only having 3 first order. You can check maybe I equal 5, I equal 6, and I equal 7. How it looks like it will canceling all the terms, and what you have left is plus or even minus at the end. Okay, at the very end it will be 3n plus 1 minus 3n plus 2 and minus 3n plus 3, and take the limit for all the n here. Take the limit as n approaching infinity, and you will see that you will get 0. Okay, you will get 0 for this first, the last 3 terms. So you will get your Sn 1 over 3 plus 1 over 6 plus 1 over 9, which is 11 over 18. Okay. Okay, still finding the sum. Well, let me start with the series, and then we have 3 power of n, and then 5 to the power of n, and then n factorial. Okay, try to check your answer. Okay, let's start working on it. I think this is a very basic, very simple. What you are going to do, you see the 3 power of n and 5 power of n. We take those two numbers and it has the same power. We can make it into one statement like that, and then n. Okay. If you remember that, we can think this as a right, which is this is equal to e to the x. Now, if we have this, means that this is e power of 3 over 5. I think it's quite simple. Now, the other questions that I want to ask, still finding the sum. This is the sum. Okay, finding the sum. Okay, pause the video and try to check your answer. Okay, now let's look on how it's going to have in the terms of the sign. The sign is changing, positive, negative, right? Positive, negative, negative. So we will have an alternate series. Let's say if we have series, let's say start from 0, then we should have positive at the beginning, which means it's just n, okay? And then we would have 1 on all the terms. There's nothing wrong with that. And then the other is it's 1, 3, 5, 7, which is the odd number. So it should be 2n plus 1, right? For odd numbers starting from n equals 0. And then the other part is 2 with power of 3, 2 with power of 5, 2 with power of 7. So this has 2 with the power of 1. So we have 2 with power of the odd number, 2n plus 1. Okay, now we need to make it into other form from this. Maybe we can simplify and make it similar to our reference. Okay. Now, if I take this and make it into the top, what I can do is I can take this in terms of 1 over 2 and then 2n plus 1 like that, right? And still this is 2n plus 1. And this is simply our tangent inverse. So if we have tangent inverse x, we will have this series, right? So this is particular is tangent inverse of 1 over 2. If you want to use calculator, you can, and you can write down the answer. Okay, now other statement, let me check. Okay, maybe we start with the using the Maclaurin series. To find the 101 derivative of the functions at 0. Okay, pause the video and check your answer at the end of the discussion. Okay. Now we can start write our function. And we can start to write and make it into our reference function 1 over 1 minus x. And then we have x, and then change into our series. This will be minus x squared power of n. And then solve this, taking out -1 to become the alternate series, and x with power to n, and we have series. Okay. Now x with power of 101 will be obtained when n is equal 50. And -150 is positive, even, right? So when n is 50, we will have so it's x with power of 101. The coefficient is is 1. Okay, and the coefficient must equal with this. Okay, so we will see that this term is equal with 101 factorial.